All right, we're going to have a look at some of the powerful API access control and protection features of Gloo Platform. We're going to use the Petstore API, and we can see that Petstore API supports for a pet resource, put, post, delete, and get, so read and write operations. Let's go ahead and view those from a client perspective. So if I want to get a list of pets, I can see that here. If I want to add a pet, let's go ahead and go to the body here and call this one Jimmy, and we'll go ahead and send that. And we can do that. We can delete a pet. Let me get an ID here. We'll delete pet number 6. And we'll go ahead and send that. And now we've deleted that pet. All great. This is what we expect. But what if we have, maybe for seasonality reasons, there's certain time periods where I don't want to allow mutating operations, or maybe based off of an upstream API issue, like there's a data corruption issue where I might want to serve the data I have, but shut off any mutating operations. I don't want to change my upstream APIs for that. What I want to do is control access to that API using policy in a dynamic way. And this is exactly what Gloo Platform supports through its use of Open Policy Agent, or OPA. OPA encodes rules in a standard language format called Rego. Our customers love using this because they can use it independently of the Gloo Platform as well. They can encode all of their authorization logic in Rego, use it across use cases, and use it across vendor tools. So they really, really like to invest in this to, kind of separate this from a vendor-specific solution. And we provide a very easy way to wire that in using OPA policies with our XDoth service. We can see here our rule is very basic at this point. We're basically just protecting the pets resource and saying only gets at this time. But you have access to the entire request context. So if you wanted to use a claim and a JOT or any other request metadata in these rules, you have that available to you. Let's go ahead and enable this specific policy and come back to our client and go ahead and say, hey, all right, we should be able to get still, so let's invoke that. We can. What about adding a pet? 403 forbidden, and deleting a pet also forbidden, which is exactly what we would expect. Now let's take another set of use cases. Imagine we have a request like this, where we are this request that is saying, hey, let's invoke the pet store, but look at this. I'm passing a query param that's trying to inject a bash shell execution vulnerability. So if I go ahead and do that, I can actually, by default, invoke that. There's no protection mechanisms. Turns out that the OWASP Core Rule Set actually has rules for what you're allowed to do with APIs and known security vulnerabilities and patterns that are best practices. We include that core rule set directly in our platform via a web application firewall policy. You can execute just the core rule set or also extend this policy to include IP allow list and deny list, header inspection. You can use it in tracing only mode to train your configuration. It's a very, very powerful feature. Here we're just going to enable the core rule set. And so now when I apply this, I should see that we come back to our query and I send that and it's forbidden. Intervention has occurred. If I clean up my query and go ahead and invoke that again, now we're back to normal. Another big concern more and more as more critical data starts to be exposed through APIs is the risk of data exfiltration. So let's take another example where our pet store added an account page and the API behind it returns, in addition to my contact information, oh, my card number's in here, my social security number, and my PIN number. All right, well, we definitely don't want that. So we provide a policy called data loss prevention that allows you to execute a standard set of rules which will automatically mask common patterns of data, but then also can be extended with regex to pick up customer-specific and use case-specific patterns as well. So if we go ahead and apply our DLP policy, now I can invoke this API again, and I'll see that we're automatically masking the problematic PII and sensitive data. All right, so we saw earlier in the developer portal demo that we used OAuth and OIDC to protect the developer portal. We can also use that OAuth and OIDC to protect APIs on the data plane as well. Let's take a look at an example. So right now, if I go to the Petstore API Pets endpoint, I have full access to that unauthenticated. What I'd love to do is use OAuth and OIDC, protect this with an authorization code flow. So to do that, I'm going to use a standard OAuth policy that wires into any IDP using OAuth or OIDC. We can see all the details here. And it's as simple as applying that to my API via policy. And now when I come back to view that API, I can see that I get redirected to Keycloak, which is my IDP in this case. Let me log in with the right credential here and password. And bam, I'm in. All right, that's all for API protection. Let's move on to API testing. When it comes to API testing, a very common requirement we hear from customers is having the ability to mock an API based on a standard design spec, and then use that for a tighter design iteration cycle with API clients. The nice thing here is that we can work with any tooling as long as it's outputting an open API spec or a standard spec. So in this case, I'm happening to use Swagger Editor for this, but any tool could be used. Once I have this design, I can actually use our powerful mocking and direct response capability to model this API and the data that it's returning. So we can see here that for these catfax, this catfax API, I'm supporting a get, a post, and a delete response. And all I have is this route table and the spec. So I'm going to go ahead and apply that now. And once I've done that, I can come into my client and I can get some catfax, which is returning the exact data that we have inside that route table across all three operations. And the great thing here is I can continue to tweak this and modify the mock data. And once I'm ready with my actual implementation, it is trivial to move over. I'm simply going to take this route table. I'm going to be able to replace this route table with the mock data with an actual route table that's routing to the real API here. So let's go ahead and apply that now. Let's see, there it is. And now we can see in our client, when I actually run a get on the catfax, we can see I'm getting actual real data from the backend system here. Even better for testing as I'm evolving my implementation. Let's say I'm keeping the contract, but introducing a new backend. I can use a cool feature called traffic mirroring to start to shadow some of that traffic over to my new implementation to begin testing it live without impacting my production traffic to my production APIs. So to demonstrate that, we're going to look over here and we have, let's say, we have our existing fax API, but now we're introduced another implementation API 2. What I want to do is I'll open the logs for that. I'm going to mirror traffic to this other API so that clients still see the normal production API, but then I can come over and duplicate that traffic as well. So let's go ahead and apply a traffic mirroring policy. And then I'll use my client again to generate some traffic. We'll do another get, do a delete, and fact 1 was not found. Let's try that again. There we go. Add a cat fact there. All right. Add another one. Now when we come back here and look at our other service, we can see that I was getting real requests or real responses in my client, but also all of this traffic was being mirrored to my up and coming V2 version of the API. We're going to stick with the Petstore API example to show off some of our advanced traffic management features, and specifically how they work to support multiple API versioning strategies. So let's say we're working with our API backend team and our API owner, and we're looking at what we return from our pets API today, and some basic information about pets and getting adopted are in here, but maybe we want to enrich this product and maybe add insurance policies to it. And to do that, we need to change the API contract. And even though we're changing the API contract in a backwards compatible way, we may want to employ different strategies for how we do that. So let's look at some of those. So the first and most obvious one is simply to have a unique path. All right, so let's go ahead and look at this. And from a routing table standpoint in APIs, you simply just provide different prefix and you have all the power to route to individual versions of the backend API. So if we just go to our API client, we can see that if I go to V1, my existing clients are getting exactly the data that they expect. But if I go to V2, now I can see some interesting information about insurance products, right? Now this is requiring clients to go to a different URL, but this is a very, very common versioning strategy. The two other most common versioning strategies that are also supported would be header routing. So if we look here, instead of going by prefix, we can actually route by header and use the same type of separation to route to different versions of the backend API. So I'm going to go ahead and apply a header policy here. And then we'll go in front here and say like, hey, and this header right now is set to v1. Let's go and send it. I get the old version or the existing version. v2, I get the one with insurance. And same thing with query parameters. So let me go ahead and apply that. And then we'll go ahead and try that out. And we can see that when I pass a query parameter v1, we get the old version, and v2, we get the new version. Now, if we want to get especially for changes that aren't necessarily going to break existing clients, maybe we're just adding to our schema, you can use a more advanced capability of canary rollouts. And so we can start testing and putting our toe in the water of the scope of this changes within our client base and start to take maybe 10% of traffic and starting with 10% of traffic and then growing from there to a larger subset of our population. So let me jump into the config and what that looks like. We can see here, we're basically doing weighted routing between the v1 version and the v2 version of this API. So let's start pretty conservative. We'll send 90% of traffic to the v1 and 10% of traffic to v2. So we'll go ahead and deploy this canary model. And then we'll come back in here and hit that endpoint. And okay, so we'll hit this. Oh, we got lucky right away. We hit it twice. In general, though, this is probably going to average out to about 90% overall. So let's go back and let's move it to 50%. And I'll go ahead and bump that up again. And of course, this could be part of your automation. This could be fed by metrics and like the number of like 500 client responses you get. And here we're seeing that at 50%, we're getting a pretty equal distribution here between them. And then finally, you know, I would probably incrementally jump this, but let's just get wild and say 0 and 100. We'll go ahead and update that and go back to our client. And now we should see all with insurance.